Design and implementation of WSN with real-time monitoring of LPG concentration for home safety. Abstract: it is common to use liquefied petroleum gas, LPG, cylinders in homes for cooking or heating, but this poses a great threat in case of gas leakage. There are several ways to avoid gas leakage: by periodic check and maintenance to the gas regulator and hoses, or using cooking devices with auto shut in case no flame is present. But with all the mentioned ways to prevent the leakage, a great chance of leakage is still exist. The proposed system is used to monitor in real time the concentration of LPG gas, propane, in ppm in home kitchen via MQ6 gas sensor, and to wirelessly send the sensed information to a Raspberry Pi server via Zigbee protocol, alerting the user via a graphical illustration the level of concentration, and if a leak is detected, the system also can take a smart decision to turn on an exhaust fan to exhaust the LPG and to keep the home safe from explosion. Keywords: LPG, MQ6, gas concentration, Zigbee, XB, IoT. Introduction. Liquefied petroleum gas, LPG, is a blend of light hydrocarbon compounds. It mainly consists of butane, C4H10, or propane, C3H8, or a mixture of both. At room temperature, both gases are colorless and odorless. Liquefied gas is heavier than air and can therefore accumulate above the ground. This may lead to LPG leaks. It is common practice to add a foul-smelling odorant to the gas to detect leaks and reduce the risk of explosions. 1. As the use of LPG in homes and cars increases, the number of accidents that may occur as a result also increases. If the cylinder is not maintained or properly monitored, gas leakage from its body or valve may occur in the whole area, kitchen, gas tank area in cars, thus a little spark will ignite and cause explosion too. In this paper, a proposed smart system can help the household's owners to detect if there is a gas leakage, and a smart action can be applied to eliminate that leakage or to set an alarm to indicate a leakage exists. A general objective: to detect LPG leakage and send the results to base station. B. Specific objective: to monitor the LPG leakage levels in ppm in real time and send the obtained data wirelessly via Zigbee protocol using XB devices. To decide if the leakage is more than the set threshold and to take an appropriate action by sending a signal to the action device, which can be any suggested mechanism for safety measure, shut off electronic valve, set the alarm, etc. 2. Proposed methodology. The purpose of this system is to detect and monitor gas leakage as part of a smart home safety system. The LPG concentration is always monitored, and when it reaches a certain threshold level, the user will be alerted, and a smart action will be taken to eliminate the danger of this leak. The proposed system is consisting of 2 nodes, the sensor node and the base station node, wirelessly connected via Zigbee 3 protocol. The responsibility of the sensor node is to monitor the concentration of LPG gas in home kitchen, and to send the data in real time to a local server, base station node, to illustrate the level of concentration and to alert the user in case of high level of gas concentration is detected, and to send a proper order to the action device. 3. System requirements. Hardware and software. The proposed system consists of the following parts. Hardware requirements. Sensor node: O microcontroller, Arduino Uno 3. O XB shield. O gas sensor, MQ6. O Zigbee transceiver, DGXB3. O action device, alarm buzzer or exhaust fans, electronic valve, etc. O Raspberry Pi 3B+. O Zigbee transceiver, DGXB3. Hardware and software description. 1. Microcontroller, Arduino Uno 3. The Arduino Uno is a microcontroller board based on a removable, dual inline package, DIP, 8MG328ABR microcontroller. It has 20 digital input/output pins, of which 6 can be used as PWM outputs and 6 can be used as analog inputs. Programs can be loaded onto it from the easy-to-use Arduino computer program. 2. SPI Shield. The SPI Shield allows an Arduino board to communicate wirelessly using Zigbee. It is based on the SPI module from MaxStream. The module can communicate up to 100 feet indoors or 300 feet outdoors, with line of sight. It can be used as a serial/USB replacement, or you can put it into a command mode and configure it for a variety of broadcast and mesh networking options. The shields break out each of the SPI's pins to a through-hole solder pad. It also provides female pin headers for use of digital pins 2 to 7 and the analog inputs, which are covered by the shield. Digital pins 8 to 13 are not obstructed by the shield, so you can use the headers on the board itself. 3 Gas Sensor, MQ6. The MQ6 module is used in gas leakage detecting equipment in home and industry. This module has high sensitivity to LPG, isobutane, propane and LNG. The module gives out the concentration of the gases as an analog voltage equivalent to the concentration of the gases. The module also has an onboard comparator for comparing against an adjustable preset value and giving out a digital high or low. Gas Sensor. Gas detected. 4 SPI3. XB is a module produced by DG International mainly used as a radio communication transceiver and receiver. It is mesh communication protocols that sits on top of IEEE 802.15.4 Zigbee standard. XB supports peer-to-peer as well as point-to-multipoint network communications wirelessly with the speed of 250 kbits/s. 5 Raspberry Pi 3B+. The Raspberry Pi 3 Model B and is the latest product in the Raspberry Pi 3 range, boasting a 64-bit quad-core processor running at 1.4 GHz, dual-band 2.4 GHz and 5 GHz wireless LAN, Bluetooth 4.2/Bli, faster Ethernet, and PoE capability via a separate PoE. The dual-band wireless LAN comes with modular compliance certification, allowing the board to be designed into end products with significantly reduced wireless LAN compliance testing, improving both cost and time to market. The Raspberry Pi 3 Model B and maintains the same mechanical footprint as both the Raspberry Pi 2 Model B and the Raspberry Pi 3 Model B. 6 Arduino IDE. The Arduino IDE is a cross-program application created in Java and is originate from IDE for the deal with a programming language and the wiring project. It is proposed to establish programming to a performer and other new users unfamiliar with software enhancement. It includes code editor with features such as syntax importance, automatic indentation, brace matching, and is also qualified of compiling and uploading a package to the board with a specific click 3. 7 Node-RED. Node-RED is a programming tool for wiring together hardware devices, APIs, and online services in new and interesting ways. It provides a browser-based editor that makes it easy to wire together flows using the wide range of nodes in the palette that can be deployed to its runtime in a single click. 4. 8 XCTU. XCTU is a free multi-platform application designed to enable developers to interact with DGRF modules through a simple-to-use graphical interface. It includes new tools that make it easy to set up, configure and test XB-registered trademark RF modules. XCTU includes all of the tools a developer needs to quickly get up and running with XB. Unique features like graphical network view, which graphically represents the XB network along with the signal strength of each connection, and the XB API Frame Builder, which intuitively helps to build and interpret API frames for XBs being used in API mode, combine to make development on the XB platform easier than ever. 4 System Operation. A proposed system flow chart. In the below flow chats, both show the steps that the proposed system takes to fulfill the required goal. Blpg concentration measurements. When the MCU is powered up, it continually asks for the status of the sensor. The code is designed to get the output voltage of MQ6 sensor and calculate the concentration in ppm, send it wirelessly to base node via Zigbee 3 protocol. C gas sensor. MQ6 gas sensor is highly sensitive to LPG, isobutane, propane. Unlike MQ2 sensor, it has a small sensitivity to smoke, that's why it has better LPG detection since avoid the noise of alcohol and cooking fumes and cigarette smoke. The sensor-based module version has a digital pin and analog pin which is TTL driven and works on 5V. For the measurement of a particular gas or multiple gases, read the analog values with the analog pin of the module, 0-5V. The analog output voltage provided by the sensor changes in proportional to the concentration of smoke/gas. The greater the gas concentration, higher the output voltage, while lesser gas concentration results in low output voltage. Arduino reads analog voltage from the sensor. Arduino has 10-bit converter means there are 1024 distinct values. i.e., 210 equals 1024. Output value equals, input value slash 1023, asterisk max output value. Here we are mapping output voltage, 0-5V, into integer value between 0 and 1023. X, 511.5 slash 1023, asterisk 5 equals 2.5V. A sensing material. MQ6 sensor is enclosed in 2 layers of fine stainless steel mesh called anti-explosion network. It ensures the heating element inside the sensor will not cause an explosion as it is sensing a flammable gas. 6. The tubular sensing element is made up of aluminum oxide, Al2O3, base ceramic and has a coating of tin dioxide, SnO2. The tin dioxide is the most important material being sensitive towards combustible gases. However, the ceramic substrate merely increases heating efficiency and ensures the sensor area is heated to a working temperature constantly. So, the nickel-chromium coil and aluminum oxide-based ceramic forms a heating system, while platinum wires and coating of tin dioxide forms a sensing system. A work principle. When tin dioxide, semiconductor particles, is heated in air at high temperature, oxygen is adsorbed on the surface. In clean air, donor electrons in tin dioxide are attracted toward oxygen which is adsorbed on the surface of the sensing material. This prevents electric current flow. In the presence of reducing gases, the surface density of adsorbed oxygen decreases as it reacts with the reducing gases. Electrons are then released into the tin dioxide, allowing current to flow freely through the sensor. V system design. A sensing node design. Measuring a particular gas requires so complicated approaches, so in order to measure a gas concentration in ppm, the following steps had been followed. I. Analysis of MQ6 gas sensor graph 5. The fig above show the sensitivity characteristics to different gases. We notice 2 parameters that are used to form these curves. The concentration of mentioned gases is expressed in ppm with respect to R/RO value. X-axis represents gas concentration in ppm while y-axis represents R/RO ratio, where Rs is the resistance of the sensor and RO is the resistance of the clear air. 2 calculations. To calculate the concentration in ppm for a particular gas, we need to determine the value of R/RO ratio of that gas and to compare it with the curve from the datasheet. This can be done by 2 steps. First we need to calculate the RO, resistance of the surrounding air. RO is determined by dividing Rs, resistance of clear air, over RO of clear air which is 10 for MQ6 gas sensor from the datasheet. Finally, the ratio R/RO is obtained, which describes the behavior of the sensor at different gas concentration 5. To calculate the concentration of a gas in ppm, parts per million, we need to derive an equation from the sensitivity characteristic of the LPG gas. We note down R/RO values with the respective ppm in a table. The program, getDataGraphDigitizer, was used to digitize the sensitivity graph to get the R/RO vs ppm values accurately. After getting the values on table 2, using Excel software to draw the curve for these values. It was observer the trend line shows the closest equation to the described curve, and the power function gets the best fit. As RO may differ from place to place depending on the temperature and humidity of that place, a calibration algorithm was designed to get the appropriate RO to any place in fresh air. This algorithm is done by Arduino Uno 3 and was logged over the period of 24 hours, after a preheat for the MQ6 coils for 48 hours as recommended in data sheets to make sure that the gas sensor is heated up and the all measurement stabilizes. The average result was taken for the calculated calibrated RO result was RO equals 0.33. B. Base node design. The base node, receiving node, consists of a server, Raspberry Pi, with a coordinator, XB3, attached to its USB port. Using Node-RED software, flowchart was designed and coded to receive the incoming information, LPG ppm value, and to display it using a graphical illustration as a gauge, also to set an if condition in case the ppm value exceed the threshold value, 1500 ppm, to send an action signal to sensor node XB to pass the command to Arduino and to take the appropriate action. Reference to a document from New Jersey Department of Health, 2100 ppm, is immediately dangerous to life and health. 8 That's why the chosen threshold value was set to 1500 ppm. 6 Work and results. The final code that will be run by Arduino consists of the below steps. 5 Send action. If the value of LPG ppm is above the threshold value, which is set to 1500 ppm, a signal will be sent from the base node to the sensor node to take an action. In this system a LED will turn on as an indicator of receiving signal. 7 Conclusion. The developed LPG monitoring system accurately measured the concentration of LPG in the experiment area. The system is integrated with IoT to send the data in real time to the homeowner. It also can be stored in database to see if a continuous leakage exists so the homeowner can check for maintenance. It helps normal people to have the needed security for their homes against leakages. The system can be installed in home kitchen in a constant way and can be either battery powered or directly powered. 8 Future scope. The system is only monitoring one home. Future work can be done to monitor several apartments in a living building, and each node can send information about the number of the apartment and its LPG status. More actions can be made, such as installing electronic gas valves that shut down in case of a leakage and can be restored to work by the main system. Minimizing the footprint of the system and build it on a PCB board will help to make system a smaller package and portable.